All right, we're going to quickly review, even though we haven't fully gone over it yet, how negative exponents work. I'm going to try to keep this brief, so enjoy. All right, so negative exponents, to me, I always think of them as I'm in the wrong place. It just indicates that if it was in the numerator, it should be in the denominator. If it was in the denominator, it should be in the numerator. For example, x to the negative a power means the same as 1 over x to the positive a. Instead of being in the numerator, it goes to the denominator. Or, similarly, if you have a negative exponent in the denominator, the rule is that it moves up to the numerator. Just the exponent is all that matters. If the number or coefficients or whatever were negative, that doesn't matter. It's the exponent being negative that means that. But why? Well, I'll tell you. When you follow the rules of dividing exponents, the rule is that you divide the coefficients, so that would be 4, and you subtract the exponents. 7 minus 9 is negative 2. Okay, so you can see now that we have a negative exponent over here. And here's what it really means. If we were going to expand this, we would have 7x's on the top and 9 on the bottom. You hear my dogs? They're so loud. Oh wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 here. 8 divided by 2 is 4, so that's why there's a 4 there. When you were in school a long time ago, you probably learned that if you are dividing something by itself, it cancels off. So all of these pairs of x's cancel off. They have a partner, and they're all canceled. So you can see what you're left with is 4 over, and you have 2 x's like that. Okay? X times x is the same as x squared. So 4 over x squared is the same as 4x to the negative 2. Okay? It just means that's kind of where they were left. There were more x's on the bottom than there were in the numerator, and so we can either put them here or there. Generally speaking, we do not write final answers with negative exponents. So if you had a choice between these two answers, this one is the way that we would want you to write it. All right, we're going to do 4 examples just to make sure that you get the general idea. All right, super important thing is to remember is that the exponent applies to what is directly next to it to the left. So this negative 2 is only with the m, all right? Which means the 3 gets to stay in its place, all right? But the m's are negative. There's negative 2 of them, so we're going to put those into the denominator and change it to positive, okay? M to the negative 2, m to the positive 2. It moved to the denominator. And just in case you couldn't see it, there's an implied fraction there, okay, over 1. All right, following the rules of exponents, this is a problem of multiplication, okay? And so we need to follow multiplication rules. The rules for multiplication are multiply coefficients. Remember, these are the coefficients. And then add exponents. The exponents of the same base, the same letter. So 4 times 5 is 20. So our new coefficient is 20. We're going to have some C's and some D's. The rule is to add, so 8 plus negative 5 is positive 3 C's. Negative 3 plus negative 1 is negative 4 D's. Okay? And like I said before, we do not want to have negative exponents in our final answer. So instead of writing it like this, it's going to look like this. 20 C cubed over D, and now the 4 is positive. This is the actual answer to this problem. All right. Next, we're going to combine using the negative exponents with the power rule. You could, and I'm going to, for sake of I don't know, consistency, do it like this. When you have the power rule, you are essentially distributing your exponent to the other exponents. When you distribute, you multiply. And when you do not see an exponent, there's an implied 1. Okay? So we're going to have 5 and y, and then multiply our exponents. 1 times negative 3 is negative 3. 2 times negative 3 is negative 6. Okay? We said that we don't want negative exponents in our final answer. So, since these are both negative, they are going to move to the denominator so the exponents can become positive. We're going to put a 1 up here to hold that spot. All right? And then we do want to multiply this. So 1 over 5 cubed means 5 times 5 times 5. 125 y to the 6th power. All right, and remember, you can pause these videos at any time to go back through the problems if you don't understand. Don't just be like, I don't get it. Like, pause it and look at it. Okay, and last one combines all the rules, I think, that we've done so far. I might need more paper, actually. Okay, here we go. This is kind of a case of follow the order of operations because even though there are variables in there, we want to make sure we go in the right order. So before we can multiply this part and this part, we're going to need to use that power rule and multiply exponents. Okay, but none of them actually have one written, so we're going to use the implied ones, and we're going to rewrite this as 3 squared x squared y squared. And I'm going to rewrite the rest of the problem around it. 2x to the 4th y cubed over 6x to the 8th y. All right, and before we multiply, we're going to need to simplify that. So we have 9x squared y squared, 2x to the 4th y cubed over 6x to the 8th y. Right, because 3 squared is 9. I'm going to highlight the changes I've made so far. We've done that part, and now that part. Okay, so that's it. All that yellow is all we've changed so far. Let's continue. Okay, whoops, there we go. All right, next we're going to use the multiplication rule to do this top part. All right, the multiplication rule says that we need to multiply coefficients. 9 times 2 is 18. We're going to have some x's and some y's. And we add exponents. 2 plus 4 is 6. 2 plus 3 is 5. And we haven't touched the denominator yet. Okay. Now we're down to a division problem, so we're going to follow the rules of division, which are divide the coefficients. 18 divided by 6 is 3. We'll have some x's and some y's. 6 minus 8 is negative 2. 5 minus 1 is 4. And you see how it's gotten so much simpler, but we can't leave a negative exponent in the final answer. So 3 and y to the 4th stay on the numerator, and we're going to put x squared underneath so that it can become positive. Okay, so that last part, all we did was we moved the negative exponent to the denominator. Okay, I hope that was a good introduction or review, depending on what you know. Have a great day.